We think of habitable exoplanets as residing in a star's habitable zone. That makes sense, right? It's the region around a star where liquid water might exist, perhaps on a rocky planet similar to Earth. But there might be another important zone, related to habitability, that astronomers have mostly overlooked: the Soot zone. Researchers at the University of Michigan said on May 25, 2023, that astronomers could expand the search for habitable exoplanets by taking the Soot zone into account. This zone in a protoplanetary disk, or planet forming, is the space between the star and the Soot line. The researchers published their peer-reviewed findings in the Astrophysical Journal Letters on May 25, 2023. Expanding the search for habitable exoplanets. The habitable zone is typically the first place that astronomers look for potentially habitable planets. That is based on what we know about our own solar system, and how the Earth has been able to hold onto its oceans and other water. Earth resides within the Sun's habitable zone while Mars and Venus are near the outskirts. But astronomer Ted Bergen, who led the study, and his colleagues want to also consider the Soot zone. The Soot zone is the space between the star and the Soot line. The Soot line, specifically, is the outer boundary near a star where solid carbon molecules are destroyed and sublimate into gas. They become volatile carbon compounds instead of remaining as solid ones. Volatiles are chemical elements and compounds that can vaporize easily. Planets in this zone may be rich in volatile carbon compounds, and those compounds could be quite different than anything on our own planet. What would such planets be like? Could they be habitable? Bergen said. It adds a new dimension in our search for habitability. It may be a negative dimension or it may be a positive dimension. It's exciting because it leads to all kinds of endless possibilities. Water-poor and carbon-poor Earth. But these planets may also be water-poor. That sounds bad for habitability, but Earth is water-poor as well. Surprisingly, our planet contains only 0.1% water by mass. Because of such little water content, scientists have long thought that Earth formed inside the frost line, or water ice line, which is farther out from the Sun. Bodies beyond that line tend to have a greater amount of water, percentage-wise, like the icy moons with subsurface oceans. We also think of Earth as carbon-rich, but, as with water, it's carbon-poor. Scientists say that while our planet was forming, it received only about 1 carbon atom per 100 that were available in the protoplanetary disk. The Soot line may be responsible for this. If the building blocks of the young Earth formed inside the Soot line, closer to the Sun, then the volatile carbon compounds would have been turned into gas. That would limit the amount of solid carbon available for the forming planet. Planets between the Soot line and frost line. The study also focuses on exoplanets born between the Soot line and frost line. There aren't any in our own solar system, but astronomers have discovered many in other solar systems. They are typically super-Earth and mini-Neptune worlds. Both are larger in mass than Earth, but smaller in mass than Neptune. They are also the most common type of exoplanets found so far. Bergen said, "These are either big rocks or small gas giants. That's the most common type of planetary system. So maybe, within all those other solar systems out in the Milky Way galaxy, there exists a population of bodies that we haven't recognized before that have much more carbon in their interiors. What are the consequences of that? What this means for habitability should be explored." Hazy methane atmospheres. The researchers modeled what these planets would be like, and found that they would likely have very hazy atmospheres. In the study, these planets, in the Soot zone, are silicate-rich, with between 0.1% and 1% carbon by mass. They also have variable amounts of water. The model suggested that these worlds would outgas volatile carbon compounds and develop methane-rich atmospheres. The methane atmosphere would produce hazes, due to interaction with photons from the planet's host stars. This is similar to how the hydrocarbon haze in Titan's atmosphere is produced. Bergen explained, planets that are born within this region, which exists in every planet-forming disk system, will release more volatile carbon from their mantles. This could readily lead to the natural production of hazes. Such hazes have been observed in the atmospheres of exoplanets and have the potential to change the calculus for what we consider habitable worlds. So, are those exoplanets habitable? This could mean that a planet like this is potentially habitable, since the haze is evidence for a possibly carbon-rich mantle on the planet. And life, as we know it on Earth, is based on carbon. But with potentially more carbon and methane-rich atmospheres, these worlds would be quite unlike Earth in many ways. Bergen added, "This is true, then there could be a common class of haze planets with abundant volatile carbon, and what that means for habitability needs to be explored. But then there's the other aspect. What if you have an Earth-sized world, where you have more carbon than Earth has? What does that mean for habitability, for life? We don't know, and that's exciting." NASA's James Webb Space Telescope, JWST, will be able to look at some of these worlds, as the paper notes. Such hazes, and the methane that drives their formation, are detectable via JWST transit spectroscopy, as demonstrated here, especially around stars lower in mass, and therefore size, than the Sun. That too, will be exciting. Astronomers say that habitable exoplanets could form in the Soot zone around young stars. They could be rich in volatile carbon compounds, different from Earth. If you want to keep yourself more informative, subscribe the channel and press the bell icon to notify you first.